Hey everyone, welcome to another Python video. In this video, we're going to be looking at a case study of object-oriented programming where we're going to try to create a deck of cards. We're going to have three classes here. The first class is going to be a card class. It's going to have two attributes, suit and rank. The suit can be any values from spades, hearts, clubs, or diamonds, and ranks can be anything from these. And then we're going to say two methods here, really. We're just going to write the getters for the suit and rank for the cards that we're creating, and we're going to make it printable as well. So we're going to start off very simple. It's going to be a card, init, self, and then we're going to say that it requires to create a card object. We're going to need the suit and rank, and we will do a privatized suit and self dot rank is going to be rank like that. And what we're going to just expect is that when we do create class card from our deck class here, we're going to assume that they're going to give us a proper suit and rank. So let's do a little property on def. We'll get the suit like so. It's a read only getter for suit. And then what we can do is just say that return self.suit. And we're going to do the same thing for our rank. That. Convert that to rank right there. And now we should be able to return our attributes to read only by having these getters set up. Then let's make it printable. We're going to go to def, string, self, return. This should be, if we're just going to print this, we're going to say self dot rank of self suit, like so. But if we're going to represent it, self, we're going to actually return a card object of self suit self rank like so. The reason why we have these two little differences, if we just print the individual card, it's just going to say like two of spades. But in this scenario here, where we're going to have many things, and most likely we're going to have a list containing all the cards and a list containing the hand of cards that we can have, it might be nicer to output something like this, where it looks like an actual card object within like different objects that we're going to put it inside. So we're going to say this is the end of class. And just to test, we can say, for example, our C variable is going to be a card of two spades. If we print C, that's all really the features that we have coded so far. We get spades of two. Oh, it's suits first. We'll go spades two. So we get two of spades, and that is our intended behavior. Let's go to our deck class. It says here we're going to need to shuffle the cards randomly. So at the top of our code, we're going to say from random import shuffle. Since the random module has the shuffle built in, we're going to be using that and so on. So we're going to create a deck class. And inside, I'm just going to create some constants here. So we're going to say suits is equal to tuple. Let's say we have spades, hearts, clubs, diamonds. Then we're going to have ranks, which is going to be a list of x's for x in range from 2 to 11. And we're going to add on jack, queen, king, and ace like so. Let's keep it consistent. We'll say it's all strings here, like that. Alrighty, perfect. So those are going to be our constants where when we have to create cards, we're going to have that. So we're going to say def. We're going to initialize the deck. then the attribute we're going to have is a deck. It's going to be equal to a list of card objects with S and R for S in suits and for R in ranks. So we are doing a double loop within a loop where we're going to have each of our suits have all these values. So spade's going to have values from 2 to 10, jack, queen, king, ace, and we're going to have those cards. And then we're going to have hearts of those, clubs of those, and diamonds of those, and this is all going to be stored in self.deck. So let's get a read-only of our deck property getter for deck. We're going to say stuff deck self return self deck. Then we're going to have a shuffle method. So we're going to say shuffle self. And it's going to be a non-returning method. We're going to take self deck and we're going to run shuffle. This is executing the random shuffle function, which we have imported right here. And we're going to need to have a deal, a specified number of cards from the top of the deck. So def deal self and num. Let num represent the number of cards to be dealt. We're going to say if num is greater than the length of deck, raise value error. Greater than the number of cards in the deck. So we're just saying that if the num was greater than the length of the deck, as in if we have dealt cards before, and if there's not enough to give out, we should raise a value error. Otherwise, we will say that we'll create a we will return self deck dot pop for range of num. I hope that works. So let's try this out now. We're gonna create a D1 called deck. Let's see. Let's try to print our D1 deck attribute and see what we get. Suits not defined. Oh, since it's defined here, we have to say self. So. Alright, and now we have all these cards in our deck attribute. Perfect. And then we're going to go with D1 shuffle. Print D1 deck again. And we have it nicely shuffled like so. And we have our representation behavior working nicely like that. Perfect. And now what we're going to do is after it's been shuffled, we're going to say print D1 deal 5. Let's see what we get. We got these 5 cards dealt in a list. So basically we remove dot pop removes the very last value in our list, and we're going to do that this many times and put that in a list and return. And that's our deal method. Perfect. Now we have to implement the player class. It's going to have a hand attribute to hold player's cards. Implement a method in player's class to add a card to the player's hand and display their hand. All right, that's just going to be a nice simple getter. So we're going to say player in itself. I don't think it needs to have anything, but we're going to say private hand is it's an empty list. All right. A method in player's class to add to the player's hand. So we can say def. I will just say add cards. self, and we will expect a list, a card list. Then we're gonna say self dot and plus equals card lists. And since we want to display the card's hand, we'll just make an read-only property getter here. So we'll do def and self, and we're going to return self._hand. Perfect. All right, so kind of player. So we can say that we have a D1 called deck object. Doesn't require anything. We're gonna ask D1 to shuffle and dealt cards. Dealt cards is equal to D1 deal of 5 cards. And then we would say we'll have player 1 equal player. And P1 add cards. We're gonna add the dealt cards. So then we should be able to print P1 hand to see what they got. And they got club of 6, 6 of clubs, 8 of spades, 7 of spades, jack of spades, and 3 of hearts. So they have a lot of spades, but nothing really significant. And there we go. That was our little case study on deck of cards. This is a really nice little setup so that you can create card games that you can use. In our card class here, we really weren't worried about what suit and rank it would be. You could write proper setters where it can do error checkings to make sure that your suits are part of spades, hearts, clubs, and diamonds. And then your ranks are from 2 to 10 to jack, queen, king, and aces. Okay. This will just need it so that we can make it printable. If we're printing a single card, we will print it as blank of suit. But if it's within like a list, like our hands or in the deck, we're just going to say it's like a card object. It behaves like a card object with the suit and the value all set up. Okay. Within a card class also, you can also implement comparison operators or override comparison operators, or even create comparison based methods so that you can create greater than less than behaviors. You can look for equality behaviors, so to make to write the logic if you were to create a game by using cards. Within a deck though, the reason why we didn't worry about what pseudo rank was going to be, because we created these pseudo constants, because constants don't really exist in Python. But we said all the suits that can be possible are tuples of spades, hearts, clubs, and diamonds, and ranks. I just did some quick list comprehension here and added these two lists together to get all the values from 2 to 10, and added jack, queen, king, and ace. And just to keep the type consistent, I converted all our range of numbers to string. Inside our initialization here, we just did a loop within a loop list comprehension here, where each card is going to take a spade value and attach all these values, and then take the next suit value and attach all thing values, and doing the same thing for clubs and diamonds. That's why we have a for loop within a for loop here within our deck attribute initialization. And since we want to maybe see the deck itself, we just wrote a little read-only property getter for our deck attribute. We used random's built-in shuffle, so we're going to call shuffle, and this is a nice little example of polymorphism occurring, how our custom deck class has a shuffle method, just like how a random class would have their shuffle method as well, but the behavior is very different. And then we created a deal method here where we have to represent what the num is. If the number is greater than the length of the deck, we were just going to rate as value. But if it's not, we're allowed to give all the cards in a deck or how many you want. And we are just utilizing the pop so that we can actually remove the values from the deck and put it into this list that we created. And a player here, we just said that the hand's going to be a list because we're going to be dealing a dealing list out basically. So whenever we want to add cards, we just created a custom method called add_cards, and we're adding whatever card list we have into our attribute called hands, and you should be able to see the hands because we wrote a little getter for it. And that is our implementation of classes. And this is a really nice starting point. With this, you can create many games. You require a lot of other logics and maybe extra methods to be added into your card, deck, and player classes. But this is a really nice starting point if you ever wanted to create a card game in Python. And as always, thank you for watching and stay classy.